Hello friends, welcome to the channel Simplify Maths. Today we are going to learn about the HCF versus LCM. So HCF means the highest common factor and LCM is least common multiple. So in the previous videos of HCF and LCM we discussed these concepts and also discussed the methods to find those HCF and LCM numbers for two or more numbers actually. So in this video we are going to discuss what are the commonalities or what are the relations between the HCF and LCM of two numbers and how they can be interrelated and what are some more interesting properties of these two. So before proceeding further, we will discuss at least once how to find the HCF and LCM of two numbers. So let's take two numbers 27 and 90 and we will be finding the HCF and LCM of these two numbers, and we have discussed some other methods to find HCF and LCM in other videos, but here we will only stick to the common division method. So let's use this method to find the HCF of these two numbers. So we start dividing by the common prime factor. So we can see 2 is not common but 3 is common. We divide by 3 and we get this, and further we divide by 3 we get this. So you can see here there is no further common factor, so our HCF is 3 into 3 which is 9. So this is number 9, and we can see here this is a common factor between 27 and 90 both. So basically this 9 can divide 27 as well as 90. So now we will use the common division method to find the LCM of the same two numbers which were 27 and 90. So in this case we again use the common division method where we write both the numbers, and in this case we start dividing them by prime numbers, and here we have to see that we don't only consider the common prime factors but we also consider the other prime factors which can divide at least one of the number. So we start with 2. It cannot divide 27 but it can divide 90, and further there is no 2 common. Then the next prime number is 3. It can divide 27. It can divide 45. Next prime number is again 3. It can divide both. Now again 3 because it is present here. It can divide 3 but not 5. And again 5. It can divide 5 but not 1. So now you see here the LCM is 2 into 3 into 3 into 3 into 5, and it comes out to be 270. So this is how we find the LCM. So now we will discuss some properties of HCF and LCM when we take two numbers. So one of the property is HCM of two numbers is not greater than any of them. So in the early example we had taken number 27 and 90, and HCM of these and this was 9. So now you can see this number 9 was less than both 27 and 90. So same way we can take another example. Let's take example of 12 and 20. So if you find HCM of 12 and 20 by common division method, there is no further common prime factor, so HCM is 2 into 2 which is 4, and now 4 is less than both 12 and 20. So basically now you got the idea that whenever you find HCM of 2 or maybe more numbers, it will always be less than all of those numbers actually, because this is a factor of all of those numbers. That's why it will always be lesser than. So next property is HCM of two numbers is not less than. For HCF it was always less than those numbers, but LCM of two numbers will be not less than any of them. It will be greater than them. So let's take again the example of 27 and 90, and its LCM came out to be 270, and this is greater than both of these two numbers, 27 and 90. So same way, if we take the example of 12 and 20 and we find the LCM, we divide by 2, then divide by 2, then divide by 3, but 5 doesn't have 3, then divide by 5, so, and 1 doesn't have 5, but we have at least once 5 appearing. So the LCM of these two numbers is 2 into 2 into 3 into 5, and this comes out to be 60. So now 60 is, you can see, greater than both 12 and 20. So you got this property of LCM. So why this is greater than these two? Because the concept is this both should be able to divide this number. That's why, and this number is the least number possible which can be divided by both of these. So that's the concept. So you got this property that LCM of two numbers will always be greater than those two numbers, and HCF of two or more numbers will always be less than of those two or more numbers. So now next property is HCF of two numbers is always a factor of their LCM. So factor, you have to take this concept. So let's take the example of 27 and 90. So the LCM of 27 and 90, it came out to be 270. The HCF of 27 and 90, it came out to be 9. And now you can see this 9 can divide 270. So for example, if we divide 270 by 9, so you see here, so basically you got the point that HCF of any two numbers can divide their LCM, or in other words we can say the HCF of two numbers is always the factor of their LCM. So this is one of an important property, and this is a relation between this is a kind of relation between the HCF and LCM of two numbers. And now this is the most common property, like most important property of HCM and LCM of two numbers. So basically what it says is the product of HCF and LCM of two numbers is equal to the product of those two numbers. So now you take the example of again 27 and 90. So the LCM of 27 and 90, this was 270. The HCF of 27 and 90, it was 9. So if you multiply the HCF and LCM, that is 270 and into 9, this is 2430. And if you multiply the numbers, so this is 227 into 90, So you see this number is same as this. So basically what we want to say is LCM into HCF is equal to product of those two numbers, which is 27 and 90, or we can simply write 270 into 9 is equal to 27 into 90. So this is one example. So let's take another example. Let's take the example of 12 and 20. So when we found in other example the LCM of 12 and 20, it came out to be 60. The HCF of 12 and 20, it came out to be 4. So now LCM into HCF, this was 60 into 4, this was 240, and if it multiply these actual numbers, this is again 240. So again this proves our concept that LCM into HCF is product of those numbers. So I hope you like this video. Thanks for your time. If you like this video, please subscribe and press the bell icon. This really helps. Thank you very much.